Hey everyone, welcome. I'm Francesco from Intrepid AI, and in this tutorial I'm going to show how easy it is to integrate an existing PX4 stack to the rest of the platform. For those who are not familiar with PX4, PX4 is one of the most widely used controllers in robotics. There is a software stack that you can download freely and execute on your machine, as we are going to do in this tutorial. And of course, there is also an hardware device, which is the actual controller, to which you can connect your propellers and actually control a physical robot. What we're going to do in this tutorial is to build a behavior using the visual tools of Intrepid AI and of course send commands whenever required to an existing PX4 stack. The PX4 stack will in turn also launch a Gazebo simulator so that we can see the drone, it's going to be a drone, flying in simulation. And of course, you are free to use the Intrepid sim. Actually, the integration is going to be a lot easier, but we have seen already how to connect Intrepid Simulator in previous tutorials. So let's see how it is possible to do the same with PX4 and Gazebo. So let's get started. So what we are showing in this tutorial is a typical behavior of starting and the execution of a sequence of tasks. In this case, we connect the onStart to the sequence node, and in this case we have 4 tasks. Of course, we start counting from 0. We are engineers after all, and the first task is PX4 initialize. Now these are not really tasks, these are more PX4 commands, but of course you can connect pretty much any task, and each task can be even a graph itself. Second task is PX4 takeoff. Then we use a delay node, which essentially waits, in this case, 2 seconds, and we connect that. Then we connect task 4, which is PX4 reposition. Essentially moves the drone to a location, local coordinates 330, and we connect task 3 over there. Now, of course, we like to debug messages and see what's going on. So we connect to a debug log. We change the data type, which should be, of course, a string. And we print the string reposition completed, if I can type. And that's it. Now, we are almost done, except that I would like to add yet another task, task 4, which is the 5th task in this case. This is going to be a parallel node. So this is the typical lingo of the behavior tree logic. And here, parallel node, we execute a PX4 orbit behavior. And in parallel to that, of course, we need to define a position and a radius, and in parallel to that we also start a delay node of let's say 5 seconds that is essentially starting counting 5 seconds from the beginning of PX4 orbit. The usual PX4 land at the end of so we orbit for 5 seconds and then we land. That's pretty much the behavior that we are implementing, and then we connect this parallel task as the 5th task of that sequence. Sequence means that we are going to execute each task one after the other. Now, the very last thing I would like to do is showing you how you can consume messages coming from the PX4. So using the PX4 log node, and we can channel the output of that node into a debug log node for Intrepid, which is printing the text generated by the controller. And we can also print the PX4 global position as it is emitted by the PX4 stack or your physical controller. And we also debug log that string. Well, it's going to be a float. So we're going to connect this to that and automatically change the type, float F64. And that's pretty much it. So this is the behavior that we are going to execute. Let's rearrange a bit the nodes for better reading and maintenance, maintainability. So we have a sequence of 4 or 5 tasks, of which one is a parallel node or a parallel task. that is 2 tasks running in parallel. And then in parallel to all that, we also debug log stuff coming from the PX4. We need to save this graph, as you can see. Now the graph is saved, and the next thing we need to do is, of course, fire up the PX4 stack, which I was preparing in another terminal. So by running the usual command make PX4 software in the loop GZ X500, we launch the PX4. The PX4 in turn will launch the Gazebo simulator that is running here, and this is going to be the space where we're going to see the drone actually moving and executing the commands that we send from Intrepid. So it's time to hit that play button and see if things work. So the drone has been armed. Now it's lifting off. That's the second task. Then we should be moving to position and orbiting for 5 seconds. Let me move it a bit here. And then after orbiting, we should land. As you can see, it is doing that. And that's pretty much it. That was cool. So we can stop the simulation. And that's pretty much it. In this tutorial, you have seen how simple it is to connect two very different worlds, which is the Intrepid runtime to an existing runtime, which is the PX4 runtime. And of course, this can be running as a software stack or even with the hardware device. There is absolutely no difference with that. As always, feel free to hit the website Intrepid.ai and discover the other tutorials for all the other topics that we have covered so far. And of course, don't hesitate to get in touch with us on the official Discord channel. You find the link on our website at Intrepid.ai.